Good day viewers, welcome to my YouTube channel. In this lecture we'll be talking about an exact type of differential equation. If you are new to this channel, consider subscribing, turn on the notification bell so that you'll be notified when a new video drops. Alright, we are talking about the exact differential equation. So what is the general form of an exact differential equation? The general form is m s comma y dx plus n s comma y dy is equal to 0, and the partial derivative of m with respect to y must be the same as the partial derivative of n with respect to x. So if this condition holds, this written form, which is this, let's say, equation 1. So in this given differential equation, it is said to be exact if you have this condition, if this condition is satisfied. So how do we arrive here? Have a function f of s comma y equals to c. Then if I differentiate this function, like the total derivative now, I will get, for this one on the left, I will have the partial derivative of f with respect to x dx plus the partial derivative of f with respect to y dy, and this will be equals to 0 because of this constant. So what that means is that your ms comma y is just this person here is equal to this, and then your ns comma y is equals to this. So how do I comparing it to the general form I gave? So this the derivative of f is equals to 0, so the coefficient of dx is the m, the coefficient of dy is the n. So this is what we mean. So I also said something here that if I have a given differential equation, so when is it said to be exact? It is said to be exact if this condition is being satisfied. Okay, let's look at some example. Okay, let's look at this example. So we want to check if this question is exact or not. So before you even solve an exact type of equation, you must know if your question is exact or not. So we have this given equation. So from this, our ms comma y is equals to y squared, and then our ns comma y is equals to 2xy. So the definition says we should differentiate. You should find the partial derivative of this function with respect to y. If you do that, you have 2y. Find the partial derivative of this function with respect to x. What do you get? You get 2y also. So you focus on the x. The 2 and the y, they are like a constant when you are doing partial derivative. So you only focus on the x. If you differentiate x, you get 1. So 1 times every other thing, you get 2y. So you could see that the m over y is actually equals to this. So if this is equation 1, you can see that equation 1 is what is exact. You could see that. So that is it. So sometimes you could be asked to find the value of a constant that will make an expression exact. Now if I have this given equation, what will be the value of a that will make this equation exact? So what do? We stick to the formula. F of m is s squared plus 3xy, and then n is as squared plus 4y. So the partial derivative of m with respect to y will be what? Will be 3x. So this one is a constant, it gives you 0. Differentiate this with respect to y, so you only have 3x left. Differentiate n with respect to x, you will get 2ax. So this equation is exact if these two they are equal. So that is what we know from the definition. So we have 3x is equals to so we have 3x is equals to 2ax. So what is a? A is equals to 3 over 2. So with that value, with the value of a being equals to 3 over 2, this equation is exact. All right, now that we know that, we know how to check if an equation is exact and all. So what we need to do next is to solve an equation. We have to solve a differential equation that is exact. So that is, we are looking for the value of the f of x. So let's consider this example now. So the question says solve the DE. So we have this given equation. So this exact? We have to check if it is exact. If it is exact, then we solve the exact type of equation. So how do we check if it is exact? Our m is 3x squared plus 4xy, and then our n is 2x squared plus 2y. So if you differentiate this, find the partial derivative with respect to y, you get 4x. Find the partial derivative of this with respect to x, you get 4x also. You could see that they are equal, so therefore it is exact. So now that you know that it is exact, how do we solve? So now we are going to, first of all, what are we looking for when you want to solve the DE? We are looking for the f, we are looking for f of s comma y. So this is the function we are looking for. Okay, so but we know something. We know that the m means m of s comma y means the partial derivative of f with respect to what? With respect to x. This is the meaning. So we are going to use this expression to get the value of f. Okay, so we are going to use that expression to get the value of f. So now we have partial of this now over this is equal to m comma y. So partial of this over this, what is m? M is 3x squared plus 4xy. So what you will do next is you are going to okay. So what you will do next is you will make f of x comma y the square root of formula. You get 3x squared plus 4xy dx. Now integrate both sides. If you integrate both sides, this d will leave. You will have f of x comma y, then integral of 3x squared plus 4xy dx. So what do you observe? You see that if you are looking for your f comma y, we just integrate our m with respect to x. So this is a formula that you should remember. So this formula will give you the value of f. So f of x comma y, but you have to take note of something also. Integrating this with respect to x, you can see that it's a curly d, it's not full d. So we are differentiating with respect to x. This is a partial integral. So we only focus on the s part, and the y is like a constant. So integrating the s here, you have 3 over 3 plus this will give you 4x squared over 2 then y. Then you know, if you integrate an indefinite integral, you get a constant. But this time around, the constant will be a function of the other variable, because we are integrating with respect to s. so it has to be a function of the other variable. So this will be s cubed plus 2s squared y plus phi of y. So we are almost there. So we need this constant that we had. We need the value of this constant. Now to get that, we will use this other property. You know, n of s comma y is equals to the derivative of f with respect to y. And from this given question, we also know what n of s comma y is. So going back to the question, it is 2s squared plus 2y. So this one is also 2s squared plus 2y. So that is what we have. So what do we do next? So we have f already. We only need to differentiate with respect to y, partial derivative with respect to y. And once you do that, this, like, let's find this. So if we do this, this will be equal to this n. So that is what we are saying. From there, we'll get the missing constant. So if you integrate this with respect to y, this is a constant. This is where y is. If you differentiate with respect to y, I mean to say, this will behave like a constant. So you get 0. Differentiate this, you only focus on the y. This will give you 1. This will give you 2s squared plus, this is a function of y, so you get prime of it. So all we are now saying is that this guy will be equals to the n. So that is what we also have here. N s comma y is equal to this. So now we equate both of them. 2s squared plus 2y. This cancel this. So we have phi prime of y is equals to 2y. So what are we looking for? We are looking for y and phi of y. So what do? We integrate both sides with respect to y. So if you do that, this becomes 2y squared over 2 plus c, which is now y squared plus c. So I know you might have in mind that, okay, why are we not writing the constant as a function of x? So take note that this phi we are looking for is a function of y. So it's just a single variable that is inside. So that is why we are having a constant. But if you look at the one we solved and then that I wrote phi of y, you could see that is a function of two variables. Alright, so that is your phi. So we are done now. So you come back to this, your f of x. So the f of x we got initially was s cubed. So we have s cubed plus 2s squared y plus phi of y. Phi of y now is now s squared plus c. So this is your f of s comma y. So you can also neglect this constant, and then you could, it's optional, it's not compulsory you write it. So you just have this. So this becomes your final result. Okay, so let's do one more example. So example 2. So solve the 2s cos y solution. So first of all, we check if it is exact. Is equals to 2s cos y plus 3s squared y, n s comma y is equals to this s squared sine y. So if you do this with respect to y, what do you get? This is a constant, you only focus on where the y is. So you get minus 2s sine y. Also here, you get 3s squared. Then also if you differentiate n with respect to x, you get 3s squared minus 2s sine y. So you could see that they are both the same, just that the arrangement is different. This is minus 2sy, this is also minus 2sy, this plus s squared, this plus s squared, they are the same. Okay, so what's next? Now they are the same, it is exact. So the next thing we need to do is to solve the DE. So how do we solve the DE? So we start from the ms comma y is equal to derivative of f respect to x. So yf now is equals to m dx. So let's look for f. F is a function of two variables. M is 2s cos y plus 3s squared y, then the partial derivative respect to x. So please make sure you are using the symbol partial derivative. Very, very important. So let's integrate this. Remember, the y is seen as a constant. You only focus on the s. So we have 2s squared over 2 cos y plus 3s cubed over 3 then y. So this will give you s squared cos y plus s cubed y. So this is your f of s comma y. Okay, yeah, when you integrate, you have to add your constants. So the constant is a function of the other variable. Okay, so we need to find this constant. To do that, remember we said our n is the same as this over y, and then we know what our n is from the question. Our n is s cubed minus s squared. We have s cubed minus s squared sine y. That is your n. So we just need to find this derivative and then we equate them. So differentiating this with respect to y, you get minus s squared sine y plus s cubed plus 5 prime of y. So let's equate both of them. Plus s cubed plus 5 prime of y equals s cubed minus s squared sine y. This cancel this, this will also cancel this. We only have 5 prime of y equals 0. So what is phi of y? So you integrate 0 respect to y, you get a constant. So it is when derivative is 0, that's when, if the first derivative is 0, it means that the function itself is a constant. So let's go back to our f of s comma y that we got. We have s squared cos y plus s cubed y, and I think we have plus phi. So the phi we had is c. So like I said, the constant is not really important. So you just get this. So this is the equation that we are looking for. Okay, so that is all. Thank you for staying to the end of this video.